Today we're going to review Amphenol Antenna Solutions remote electrical tilt antenna systems. We will begin by addressing the RET system and its components. A typical remote electrical tilt antenna system contains three main components: the remote electrical tilt antennas that correspond to the Antenna Interface Standards Group or AISG technical standards, a transport mechanism such as a long AISG cable or coaxial feeder line modem combination, and a controller. Amphenol Antenna Solutions supplies each of these main components. Amphenol's RET antennas may contain three different kinds of RET units. Some will have an external RET unit. These units have the motor and position sensor completely enclosed in a watertight unit. They attach to the bottom of the antenna. There are also two different kinds of internal RET units: a multi-device control unit, or MDCU, which can control up to 16 separate motor and phase shifter subassemblies for multi-band, multi-sector antennas, and an internal cassette-style RET unit, which is used in our single-band WBX-style antennas. All of these RETs contain the same firmware set using AISG 1.1, 2.0, or Ericsson mode, and can be mixed within an operator's antenna system. Communication between antennas can be accomplished by using a daisy chain installation by using a standard AISG cable with 9-pin circular connector. Communication from the AISG controller to the antenna system can be achieved by a home run cable, which is a long AISG cable running the length of the tower, or a Smart Bias T system. Smart Bias Ts contain AISG modems which allow AISG control and DC power to be injected into the main feeder line. The bottom bias T injects the signal and DC current into the feeder line, and the top bias T removes the DC current and AISG signal from the main feeder to power and control the antenna RET units. There are three basic types of control units for Amphenol's RET systems: the PCU4 portable control unit with antenna line device control software, or ALDC, the site control unit, SCU, and OEM Node B control. The PCU4 is a compact control unit that connects to a field technician's portable computer via a USB cable. The ALDC software resides on the computer and can be downloaded from Amphenol's website. We will review this software and how it is used to control the RET units later in this video. The Amphenol SCU is a compact AISG device controller. The product is designed to be wall or rack mounted inside the base station equipment cabinet and provides remote access to AISG compliant devices at the site. The device can be controlled locally using a laptop computer or remotely via an Ethernet connection. The third type of control is via the operator's OEM Node B. This type of control is outside the scope of this video. Here are two different Amphenol antennas, one with an external RET and one with an internal MDCU. All Amphenol variable tilt antennas can be ordered as either manual or remote. An antenna with remote capability using an external RET cannot be controlled manually. MDCU type antennas have the ability to be manually controlled. Simply remove the protective cap and turn the thumb screw. This cap must be put back in place in order for the MDCU to control the antenna remotely. All Amphenol manual electrical tilt antennas have the ability to be upgraded to remote by purchasing the correct RET unit. It should be noted that all Amphenol RET units are AISG Type 1, not Type 17. The MDCU behaves as multiple Type 1 RETs and should not be confused as a Type 17 multi-RET unit. Here is a Smart Bias T system containing a top and a bottom unit. The feeder cable is short for the purpose of this video. There will be a top and a bottom unit. These are not interchangeable, as the top unit has a male AISG connector and the bottom has a female. All Amphenol Smart Bias Ts are clearly marked top and bottom. Additionally, there is an indication of where the feeder and jumper lines are connected. The Smart Bias T will not supply power and AISG signaling to the RET units if the connectors are reversed. Here is the Amphenol PCU4 portable control unit. It contains the PCU4, power cable and 24-volt transformer, a 1-meter AISG cable, and a USB cable. There are 4 LEDs on the unit: a power LED, a 12-volt LED for specific AISG 1.1 purposes, and a transmit and receive LED, which will flicker when the unit is communicating with the RET antenna. The unit also comes with a CD which contains the ALDC software. This software is also available on Amphenol's website at www.amphenol-antennas.com. Here is the Amphenol SCU-003-01 site control unit. The purchased unit will contain the SCU and rack mounting bracket. It's powered by negative 48-volt power located at the radio site. An Ethernet crossover cable is needed for initial setup and local control. A standard Ethernet cable is necessary for remote Ethernet use. Antenna line device software installation. The ALDC software must be installed on the user's laptop to use the PCU4. We will review the process by downloading the software from Amphenol's website. The antenna line device control, or ALDC system, contains a portable primary controller, the PCU4, and software used for configuration and control of AISG version 1.1 and or version 2.0 devices at a cell site. The antenna drivers and ALDC software are installed on the user's computer. Setup preparation. Make sure prior to setup that the ALDC system you receive includes the following: portable control unit, or PCU4, a USB data cable, an AISG control cable, and 24-volt power supply. Also included is the ALDC software version 2.0 for Microsoft Windows. The best way to obtain the latest software is to download it from the Amphenol website. Note, before installing the RET antennas, Amphenol strongly suggests connecting each actuator to the controller, either a PCU4, Node B, SCU, or other antenna vendor controller, and testing the connection on the ground. Doing so will ensure that each antenna is in working order prior to climbing the tower, which might prevent reclimbing the tower. Important: the PCU4 USB cable must be disconnected from the computer's USB port during the software installation process. If the USB cable is connected to the computer, the USB RS-485 drivers will not load properly and programming the RET will not be possible. The following download, extraction, and installation process was shot using a Windows 7 device. Your screen may vary. Download from the Internet. On the control computer, open a web browser, such as Internet Explorer, and go to the Amphenol Antenna website. The web browser screen displays the Amphenol Antenna's homepage. Select Products, Remote Electrical Tilt Technology from the pull-down selection list. The web browser opens the Remote Electrical Tilt homepage. The Remote Electrical Tilt Technology page displays several links to files that can be downloaded. Click on the Antenna Line Device Control Software, ALDC, version 2.0 for PCU4. The screen opens the window to confirm downloading the compressed file that includes the ALDC software. Click the Save button and select your PC desktop as the target download location. The screen will display the download status, and when completed, the file Amphenol Antenna Solutions ALDC 2.4 for PCU4.zip is on your computer. Extracting ALDC software. Click on the file Amphenol Antenna Solutions ALDC 2.0 for PCU4.zip. The screen displays the Extraction Wizard tool. Click the Next button to extract the files. When it is finished, click the Finish button. All of the files you need to install the ALDC software have been extracted into the target directory on your PC. The target directory displays the folder Antenna Line Device Control Software version 2.0 for PCU4. Installing the ALDC software. Double-click on the folder Antenna Line Device Control Software version 2.0 for PCU4. The folder contains an auto-run utility and the installation folder. Double-click the installation folder to open it, and then double-click on the setup icon to start the ALDC version 2.0 setup tool. A confirmation window will appear. Click Run, which will cause a new window to appear. Leave both installation options checked and click the Next button. Do not click the Close button on this window while the installation is in progress, because that will interrupt the installation. When the installation is complete, your PC desktop displays the software icons and alerts you that the USB driver has been installed. Now plug the USB connector from the PCU4 into one of your computer's USB ports. If your speakers are enabled, you should hear an audible tone after the PCU4 connects. Click on the ALDC icon on the desktop to start the application. The screen displays the ALDC home screen. Check the port COM number at the bottom of the home screen. Any number other than 0 means the USB cable is connected and detected by the system. Connecting the RET antennas to the controller. We will now review how to connect the AISG home run cable to the PCU-4 controller. Again, it's highly recommended to test the antennas on the ground prior to installation. Connect the female end of the AISG cable to the RET unit. Hand tighten only. Over-torquing with a wrench or pliers may damage the RET connector. If daisy chaining, connect the male end of the AISG connector to the female of the first unit and the female end to the second RET antenna. Repeat for additional antennas. Connect the first AISG cable to the PCU-4 controller. Again, hand tighten only. Make sure the power LED is on and solid red. A dim or flickering LED may indicate a DC block in the system, primarily if smart bias-Ts are being used. Check the coaxial jumper and feeder system to make sure there are no devices, such as lightning protection or circulators, that will block DC current from the controller to the RET antennas. Check the COM port number at the bottom of the home screen. Any number other than 0 means the USB cable is connected and detected by the system. If the number is 0, the system is not properly connected. Either the USB cable is not connected with the adapter, or the USB connection is not detected by the Microsoft Windows system. In the latter case, please reconnect the cable and launch the system again. Product functions. The major functions provided in the ALD system include antenna remote electrical tilt, remote azimuth steering adjustment, the AISG TMA adjustment. It also includes device calibration and device configuration. Using the ALDC system software. Device scan. The scan function will interrogate the AISG bus and display all AISG devices found. RET device types will display on the RET panel. TMA devices will display on the TMA panel. Initiating the scan function. To initiate the scan function, either click on the scan device icon in the toolbar or select Scan Device from the main menu. The screen displays a verification window. Click OK to begin the scanning process. During the scanning process, the transmit and receive LEDs should flash on and off to indicate data transmission in both directions. Scan results. The ALDC device status window displays all found RET devices. RET devices are automatically sorted by sector ID. After a scan, the main screen will show a number of attributes: the device name, sector ID, bearing, which is the antenna bearing in the range from 0 to 359 degrees, the frequency band, the vendor name, the antenna model, the antenna serial number, the RET serial number, the electrical tilt value, any mechanical tilt value, the total tilt, which is the sum of the mechanical tilt and the electrical tilt, and the device status. The device status will show an OK or a device alarm message if there is a problem. Additional information about the serial number. According to the AISG standard, each device must be assigned a unique identification number, or a unique ID number. It's defined as the vendor code followed by a device serial number. Amphenol Antenna Solutions displays one of two unique IDs on each RET or TMA product shipped. This code can be either JB for J-Beam Wireless or AI for Amphenol Antenna Solutions. Toolbar commands. Commonly used commands for each device type are displayed at the top of each panel. Click on a line to select a device. The line will change to a highlighted color. Click on a command button. It can be either Set Tilt, Clear Alarm, Self-Test, or Reset. The Clear Alarm, Self-Test, and Reset functions are rarely used. For more information on these, please consult the ALDC manual found on Amphenol's website. Set Tilt. Click the Set Tilt button on the toolbar. The screen displays the Set Tilt dialog box. Change the current tilt value and then click the Set Tilt button to initiate the process. The Set Tilt status window displays that the new electrical tilt value has been applied successfully. Click the OK button to close the message window. RET detail settings. You can edit device information using the ALDC software. To display the detailed data for the selected device, click the Edit button on the toolbar menu or double-click on the highlighted row for the device. The screen displays the RET detail setting. There are 6 specific user-defined settings that may be used by the operator: the sector ID, the site ID, the installer ID, the installation date, the bearing, and any mechanical down tilt a particular antenna may have. Changing the installation information. Type the new data in the appropriate field. Check the box beside the field that you would like to update. Note: only the field with a check in the checkbox will be uploaded to the RET. This is intended to prevent accidental changes. Click the Save Selected button to upload the revised information to the RET. Antenna model data. There are 5 attributes that conform to the specific antenna being controlled. The antenna model. The antenna model has been set by Amphenol at the factory. This field would rarely need to be touched by the operator. Frequency band. This is the frequency band or bands used by the antenna. The beam width. The beam width for each band in frequency order. Antenna gain. This is the gain for each band in frequency order. Changing the antenna model. It's only appropriate to upload a new antenna model to the RET device in the following circumstances: when transferring a RET unit from one antenna model to a different antenna model, and when upgrading the configuration file in the RET to a new release. Note: it is rare that a new configuration file is required for an Amphenol RET device. Only upload a new configuration file when instructed to do so by technical support. Please consult the ALDC manual located on Amphenol's website for more information. RET model data. There are a number of attributes that conform to the specific RET being controlled. These include the status, the vendor, either Amphenol or J-Beam Wireless, the RET model name, the RET serial number or unique ID, the RET hardware version, the RET software version, the minimum and maximum tilt. This is the allowed electrical tilt range of the selected antenna, and current tilt. Tilt settings should be in the range of the min and the max tilt. This data is part of the RET's personality and cannot be changed by the operator. Get tilt. This function interrogates the RET and then returns the current electrical tilt setting of an antenna. Using the get tilt function, click the Get Tilt button on the toolbar. The screen displays a message when the software settings have been reset. Click the OK button to close the message window. Set Tilt. This function provides a second location within the software to change the electrical tilt of an antenna. Select the Set Tilt button on the RET Details Setting toolbar. This will initiate the process. The screen displays a Set Tilt software progress window. The screen displays a message when the Set Tilt setting has been reset. Click the OK button to close the message window. Calibration. The Calibrate function initiates a calibration command to the selected device. The calibration command is required by some manufacturers to automatically calibrate the RET actuator to the antenna. For all Amphenol Antenna Solutions devices, electronic calibration is not required. When a calibrate command is sent to the RET, the device will change the tilt to maximum tilt, then to minimum tilt, and then return to the current tilt setting. Using the calibration function, click the Calibrate button on the RET Details Setting toolbar. This will initiate the process. The screen displays a warning about site coverage that will change during calibration. Click the OK button to proceed. The screen displays a Calibrate Progress window. The screen displays a message when the calibration is complete. Click the OK button to close the message window. Site Report. The site report provides the ability to save a record of all device information at a site into a CSV format file. The default file name is report.csv. This file is a comma-delimited ASCII file that can be imported into Excel to allow easy sorting and formatting of the recorded site information. Using the site report, select File, Export Site Report from the main menu. The screen displays a Save As dialog box. Create a folder for saving site logs. Adopt a log naming convention to identify the site name and the date when the log was created. Important. The CSV format log file can easily be imported into Microsoft Excel or into Microsoft Word tables. All data fields associated with each device type are deposited into the log file. This file creates a record of the site configuration at the time the log file was created. Download software for RET and TMA. This function provides the ability to upload new firmware to selected AISG devices. This feature can also be used to upload a small hex file to selected Amphenol RET devices to change the operating mode from AISG 1.1 to AISG 2.0 and vice versa. Downloading software. Click the Download Software button on the RET Details Setting toolbar. The screen displays a window where you can select the file to upload to the device. Note, the software program provided by the device vendor must have either a .bin or a .hex extension. Select the software file and then click the Open button. The screen displays a confirmation window. Click the OK button. The system downloads the software file. Note, the software download might take up to 20 minutes depending on the file size. The screen displays a message when the software download is finished. Click the OK button to close the message window. Note, when switching the AISG operating mode of an Amphenol RET, it may be necessary to rescan the bus in order for the software to establish proper communication with the device and to display the updated AISG version. Site Control Unit, or SCU. The SCU is a site controller for AISG devices installed at a cell site. It's compatible with the AISG standard and can control up to 24 AISG 1.1 and 2.0 devices such as RETs and TMAs. It provides a web interface performing antenna tilt adjustment, TMA mode adjustment, and device monitoring from remote locations. Installation. The front panel of the SCU system has 1 or 3 8-pin AISG female ports used to connect the SCU to a network of AISG devices, a power port, a reset button, USB port used for factory programming, an RS-232 port used to connect a console to the SCU, an Ethernet data connection port, and LED status indicator lights. The web-based client system requires Internet Explorer 6.0 or above and a screen resolution of 1024 by 768 or higher. Hardware setup. Connect the Ethernet port on the SCU to the LAN port of the PC using the crossover cable. Connect negative 48 volt DC power to the power port on the SCU. Connect the AISG female port on the SCU to the AISG network control cable. Change the TCP/IP settings on the PC by going to the Start menu and selecting Control Panel, Network and Sharing Center, Local Area Connections, Properties, TCP/IP version 4, Properties, then select Use the following IP address and enter the following values. IP address 192.168.0.31, subnet mask 255.255.255.0, default gateway 192.168.0.31. Select OK and then close. Log on. Launch the web browser application such as Internet Explorer and go to http://192.168.0.30. This is the default address. The following screen should appear. Log on using the default login account. The default account has full authority for access and management. The username is admin, all lowercase. The password is also admin, all lowercase. System configuration. The system setting panel is used to set up system parameters for SCU operation. We will only focus on the network setting parameter in this video. Network setting is used to set the following for the SCU system for remote system management: the IP address, the subnet mask, the gateway IP, and the SNMP server IP address. This is typically not used. Change the default IP address for the SCU to the assigned address for operation in your network. Click the Save button. Click the OK button to initiate the save process. Using the SCU system. For RET or TMA device status. All the RET and TMA devices at the base station site that can be controlled remotely are listed on the device status panel. RET antenna down tilt and or the TMA mode and TMA gain can be adjusted remotely through the detail panel. In the device list, a device will be listed in the RET or TMA list according to its device type. The important device information for each device is retrieved from the device memory and stored in the SCU memory for display. Device information will be updated after any scan, refresh, reset, and or add device section. Scanning. Click the Scan button, then the OK button to initiate the scan process. The device status panel will be updated when the process is finished. Click the Close button to close the process window. Click the Save button before navigating to other panels, in order for the scanned information to be retained in the SCU memory. Click the OK button to save the device information. Uploading new data to a device. Click the detail link for a device in the device list. A new antenna data window will open. Type the new information in the window. Click the checkbox to the left of the data field as shown. The act of checking the checkbox is intended to prevent accidental data revision. Click the Save Select button to upload all revised data fields. All other RET functions, in addition to TMA functions, are fairly self-explanatory and can be found on the Amphenol website.